So in the previous video, there was a little mistake there at the end. The actual answer to the one over here on the right is not -1. That's the answer to the subproblem. The answer is e to the -1, and we'll actually go ahead through the steps to make sure we know how to get that. So what we're going to do is that same setup. So I'm going to go ahead and erase this just so we know how to go through the work ourselves. The setup involves us just looking at the cancellation between the inverse and the exponential. So by the way, you could even check this is going to be 0 to the, let's see, you would have -0 to the -1 over negative infinity. So you have this same type of indeterminate form, and you'll even see this as we pull things in like we did on the last problem. All right, so let's consider the limit as x approaches 0 from the right-hand side. And then we'll rewrite this as e to the ln of x to the -1 over ln of x. So again, we have this subproblem that we're going to look at inside. So here is the subproblem that we're going to want to focus on. So let's pull the limit inside. So it's e to the limit as x approaches 0 from the right of x to the -1 over ln of x. So again, the limit came inside the composition. So that means we should have an ln here. So what we're going to do is bring the power out in front of the ln. So we have that subproblem there. So we're going to just focus on this subproblem just like before. I'm going to do it in green. That's not green. That is blue. So let's do it in green. And we have the limit as x approaches 0 from the right of ln to the x to the -1 over ln of x. Power rule says that this comes down in front of the ln. So we have the limit as x approaches 0 from the right of -1 over ln of x times ln of x. Well, you could even see here, well, what's going to happen? You could go ahead and use L'Hôpital's rule, but this is even easier. Notice that we have the same thing at the top and the bottom, so that cancels with that, and we have just the limit as x approaches 0 from the right of -1. The limit of the constant is the constant, so that is where the -1 comes from. So it didn't even really need to use L'Hôpital's rule here. We just went ahead and looked at that same trick of pulling everything, the limit inside the composition, using the inverses. So now returning to our original problem, this is the purple part right here. So we'll go ahead and just replace that purple part with -1, and we see that the limit as x approaches 0 of our original function, which is x to the -1 over ln of x, is equal to e to the -1.